want to welcome you to today's facilitation class. And today also we'll be beginning our facilitation on introduction to soil pedology and classification. We will be looking at this very important course. It's a very vital course in the study of soil science, because you need to understand that soil is basically divided into two groups, or two broad ways when we want to study soil. And one of them being soil pedology. The other one is soil edaphology. Edaphology has to do with study of soil with respect to plants or high plants, also called agronomy, so to say. But when we talk about soil pedology, we're talking about soil as a naturally occurring entity. We're talking about soil as a naturally occurring body. And we cannot study soil effectively without trying to understand how soil is formed, what are the factors that are responsible for the formation of soil, what are the rules of some of those factors, what did they do, how did they come to be. And these are some of the things we'll be looking at today. I'll be looking at in this very course. However, today we have a very important topic that will be introducing us into this very course. And the topic we'll be looking at today is soil origin and formation. Soil origin and soil formation. Now, when we talk about the origin of soil, we'll be talking about learning the interactions, the factors that came into play to bring about soil as an entity. We already know that soil is an interface between the atmosphere and the lithosphere. Of course, the lithosphere has to do with the mantle of rocks that makes up the Earth's crust. So soil has an interface with the hydrosphere as well. It has to do with the water, the oceans, the seas, all that represents the water bodies on the surface of the Earth is called the hydrosphere, and soil also interface with it. Soil sustains the growth of many plants. Soil serves as a habitation for animals as well. And soil forms also basically part of the biosphere. So a combination of physical, chemical, as well as the biotic factors all act together on the organic as well as the weathered rock fragment to produce soil with a porous fabric that contains water as well as air, or the pedosphere. So when we consider soil as a natural body of mineral and organic material that is formed in response to many environmental factors as well as processes that act on and changing soil permanently, we say that soil pedology has to do with studying soil as a natural body. We are also saying that there are a lot of minerals as well as organic materials that could be formed in response to these environmental factors as well as the processes that act on soils, thereby changing them permanently to form a new soil. So soil have been cultivated intensively for at least 550 years And only about 5,500 years, excuse me, only about 2,000 years ago, some crude soil fertility relationships were proposed for crops. The need for water was quite clear, and most of our scientific knowledge has been accumulated in the last 70 to 90 years. Now, the objective we're looking at in the course of this facilitation today is that at the end of studying this unit, you should be able to understand soil quality as well as the combinations of soil. Now, what's you need to understand, where did soil come from? How did soil originate? What exactly is the meaning of soil formation? How does soil come together to form? So soils are a mixture of different things. Yes, the components that bring about soil may include rocks, may include minerals, may include even dead and decaying plants and animals. All of them in the soil are all called soil. So soil can be very different from one location to another. However, generally, soil consists of organic as well as inorganic materials, which include water, organic and inorganic materials, as well as water and air. These are the four basic components of soil. When you see a soil in its natural state, all of these four components must be in it: organic substances, inorganic materials, water, and air. So the inorganic material are the rocks that have been broken down into smaller pieces. So the size of the pieces may vary. However, it may appear as pebbles, may appear as gravel, or as particles of sand or even clay. The organic material is decaying living matter, and this could be plant or animal that have died and decayed until they become part of the soil. So the amount of water in the soil is loosely linked to the climate and other characteristics of the region. So the amount of water in the soil is one thing that can affect the amount of air. Very wet soil, each are found in a wetland, probably has very little air. The composition of soil affects the plant and therefore the animals that can live there. Now, what are the origin of soil? Physical, biological agents such as wind, running water, temperature or temperature changes, and living organisms perpetually modify the Earth's crust, changing its upper surface into products that are more closely in equilibrium with atmosphere. So the hydrosphere as well as the biosphere. So Earth science sum up all the processes through which these alterations take place under the collective term known as weathering. Now, one speaks of mechanical weathering in the case that the dominant forces are mainly mechanical, such as the eroding action of running water, the upgrading action of streams, load, or the physical action of wind, as well as severe temperature fluctuations. Similarly, one speaks of biological weathering when the forces producing changes are directly or indirectly related to living organisms. Of these, we can mention several examples such as the action of burrowing animals, the penetrating forces of plant roots, and the destructive action of algae, bacteria, and their acid-producing symbiotic community of the lichens, or simply the destructive action of man, who continuously disturb the Earth's crust through various activities. Processes of disintegration, during which mantle rocks are broken down to form particles of smaller sizes without considerable changes in chemical or mineralogical composition, are known as physical weathering process. Now, soil formation. So far, we've talked about the origin of soil. But this time around, we'll be looking at soil formation. So soil are that portion of the earth crust in land plant or in land that plant can grow. So if water and temperature are adequate, at least the minimum nutrients are available and toxic substances are in low concentration. Some soils are very shallow, few centimeters deep, and some are few meters deep. All soils develop from weathered rocks, volcanic ash deposits, or accumulated plant residue. So most soils are formed weathered rocks and minerals. These minerals include quartz, feldspars, micas, hornblende, calcite, gypsum, and combination of minerals into soil masses are called rocks. Now, the objective of this is at the end of this unit, you should be able to explain the origin of organic soil, classify the origin and nature of certain landforms, and moraine, alluvial deposits, loess, pits, muck, and define the meaning of soil formation and soil development, as well as the processes active in soil changes, and evaluate soil forming factors. Now, soil formation, if we are to look at it at a glance, at some of the methods used by these skilled soil makers, heat and cold are working partners. You already know that most hot bodies shrink or contract on cooling. The early rocks were hot as the outside shell of rocks cooled from exposure to air and moisture contracted. This shrinkage of the rigid rim of course broke many of the rocks, and here and there left cracks or fissures. In these fissures, water collected, frozen. As freezing water expands with irresistible power, the expansion still further broke the rock into pieces. The smaller pieces, again, in the same way, were acted on by frost and ice, and again crumbled. This process is still a means of soil formation. Now, running waters were another giant soil former. If you would understand its action, observe some usually sparkling streams just after a washing rain. The clear water are discolored by mud washed in from the surrounding hills, as though disliking their muddy burden. The water strives to throw it off. Here, as low banks offer chance, they run out into shallow and drop some of it. Here, as they pass a quiet pool, they deposit more. At least they reach the still water at the mouth of streams, and there they leave behind the last of their mud load, and often form of it little three-sided. Also, we have glaciers, which were another soil-producing agent. Glaciers are streams, frozen and moving slowly, but irresistibly onward, down well-defined valley, grinding and pulverizing the rock masses detached by the forces and weight of their attacks. So we now have to talk about the type of soils. Sand, silt, and clay are the basic type of soil. And most soils are made up of a combination of these. So the texture of soil, however, or how it looks and feels depend upon the amount of each one in the particular soil. So the type of soil varies from place to place on our planet and can even vary from one place to another, even in your backyard. What are the soil forming factors? Even if all soils were formed through the same weathering process, they could still differ because of other influences. So we have 5 items called soil forming factors and are primarily responsible for soil development. They include the parent materials, the climate, which are principally temperature and precipitation, biota, which include living organisms and organic residues, topography, which has to do with slope, aspects, and elevation, and the last being time. Parent material influence, parent materials influence soil formation by their different rates of weathering. The nutrients they contain for plant use and the particles size they contain, which may be sandstone or sandy, conglomerates or rocky, shales or clay. The less developed the soil is, the greater will be the effect of parent material on the property of that soil. However, even the properties of well-developed soil will be greatly influenced by its parent material. Clay formation is favored by a high percentage of decomposable dark minerals and by less quartz. The result of leaching and many translocations, as well as transformation, are affected by water movement in soil, will be evident even when the soil is well developed. All soils at the lowest category of soil classification, such as series, are placed into separate series if parent materials are different. Now, climate and soil formation. Climate is an increasingly dominant factor in soil formation with increased time, mainly because of the effect of precipitation as well as temperature. So some direct effect of climate on soil formation include the following. You have a shallow accumulation or retention of lime or carbonate in areas having low rainfall or where low rainfall occurs because calcium bicarbonate from dissolving carbon dioxide as well as minerals and lime are not leached if sufficient water is not present. Such soil are usually alkaline. Acidic soil form in humid area due to intense weathering and the leaching out of basic cations. Basic cations are calcium, sodium, magnesium, and potassium. Erosion of soil on sloping lands constantly remove developing soil layers. The position of soil material downslope cover developing soils. Also, weathering, leaching, and erosion are more intense and of longer duration in warm and humid regions, especially as in Hawaii, where soil does not exist. Biota and soil formation. The activities of living plants and animals, as well as the decomposition of their organic waste, residues, the living environment, the biota, have marked influence on soil development. Differences in soil that have resulted primarily from difference in vegetation are especially noticeable in the transition where trees and grasses meet. In Nigeria, for example, the different soils follows closely the difference in vegetation types. There are more walks from earth. The vegetation gets sparser as it gets shallower and fewer in organic matter. Topography and soil formation. The earth's surface contour is called its topography, sometimes called relief. So topography influences soil formation primarily through its associated water and temperature relations. Soil within the same general climate area developing from similar parent materials and on steep hillsides typically have thin A and B horizons because less water moves down through the profile as a result of rapid surface runoff and because the surface erodes quite rapidly. Similarly, materials on gentle slope hillsides have more water passing vertically through them than do materials on steeper slopes. The profile on gentle slope generally is deeper. The vegetation more luxuriant and organic matter level higher than in similar material on steep topography. Conclusion that soil originated from the decay of rocks and minerals by a combination or combining with organic matter. It takes some 100 million years for soil to form. So soil is a combination of rocks, mineral fragments, species made by weathering, so with agents such as wind, rain, sun, snow, etc., and organic matter, both living things and non-living things, and water as well as air. So these are some of the things we have to look at today in our facilitation of today. Of course, you may know very clearly well that it is very, very important and vital that you take time to go through both the course materials, and also on the e-learn, on my page here on the e-learn, you can as well search for the instructional video for each of the units of the course. The instructional videos have been kept in a very creative way to enable you to learn with ease. You learn with some ease and all of that. So all of these have been put together for you. As I said in the beginning of this course, that this course is very important, because if you can take out time to learn this course, you will be able to understand that the course has a lot to do with soil origin, soil formation, some of the factors that are responsible for soil formation, and what soil is all about generally. By the time you're done with this soil, this course, remember, is about soil pedology and soil classification. Of course, in soil classification is very vital part of soil study, and it takes somebody who have a very good knowledge of soil pedology to be able to talk about soil classification. This is because soil on its own has so many factors, and in terms of classification of soil, there are so many things taken into consideration as we talk about soil classification. In fact, we have the 6 levels of soil classification, which include the soil order, the suborder, the soil grade group, the subgroup, and we have the families and the series. Families, and these are the major ones. So when maybe in this course, you may just be limited to the order, soil order. And when we talk about orders, we're talking about 12 soil orders according to United States soil taxonomy. And in those orders, you could see there are ones they call arphisors, there are ones we call ortisors, there are ones we call spodosors, there are ones we call vertisors, there are ones we call aridisors, and several other things. We even have ortisors, and so on and so on. There are about 12 of them. And when you try to study this, you get to know what exactly is responsible. Like, for instance, the soil that is called aridisol, from the word arid regions are more like the desert regions. So soils that are of the desert region are called aridisols. And of course, there are so many characteristics of such soils, because they could be high in salt because of very low rainfall and several other factors, affecting them. We also have insectisols. Insectisols are soils, they are also similar to entisols. Insectisols and entisols, they are similar. Both of them are young soils, and one of their major characteristics is that they don't have well-defined horizons, because they are just young. Their horizons are just coming up gradually, and most of them are found in mostly lowland areas where there are depositions of soil particles by agents of stream waters or flowing waters that are coming from the lowland, from the upland down the lowland, and all of that. So these are some of the factors employed. So when we now talk about vertisols are also soils in the lowland areas too. But however, it has a lot of clay in it. Some of the major distinguishing factor is noticed in vertisol is that during the dry season, the soil will begin to crack. After that, the soil must have dried up and there's the moisture in it have been taken. The soil will now begin to crack. However, in the rainy season, the soil will begin to swell and come together and very slippery. And because it has quite some clay content in it, what you have the ortisol, which are basically soils that are found and are more in the tropical region, soils of the tropical regions, because the soils have experienced extreme weather conditions. They have had experience in extreme weather conditions. Of course, the tropical areas are areas where we have excessive rainfall, we have excessive sunshine. Everything is just in excess. So because of that, the soil in question here have experienced all of that. Because of that excessive rainfall, there is what we call both alluviation or illuviation, whereby there is clay movement from the upper soil down to the subsoils or the B horizons. You see a lot of clay accumulation, you see clay deposit, you see clay movement, and all of that in those horizons. So these and several other things are what we'll be looking at in this our facilitation. So I encourage you to study your course material very well, do the much you can. If there are any question you want to ask, there are several channels through which you can get to me, especially even on the course page here or through email. Anyhow, get across to me. If there's anything you don't understand, let me know about it. And I assure you, I will do my best to put you through, because my joy is that you do well and do well in this very course and pass this course excellently. So I want to welcome you once again to the course. I encourage you to do your best to always participate in this course. Find out the timetable. We'll be doing it every Thursday, 2 to 3 p.m. And I will always do my best to send you a message to give you a reminder shortly before any of our classes, at least a day or a day before the day of the class. So do your best to participate in this class effectively, and you will be glad you did. So once again, I want to say welcome to this course, and God bless you as you continue to participate in it. Thank you very much, and see you same time next week. Thank you and remain blessed. Bye.